Hello everyone, welcome to another video. Today we are going to create a computer vision application using Streamlit. This application will allow you to select a picture, and after you select a picture and include it here, it will allow you to analyze it, and then based on artificial intelligence it will first generate a description. So here you can see we have this picture of the Eiffel Tower from Paris, and it has generated as this caption, a number of alternative captions over here, and then some tags of what we can see in the picture. We will do it using Python and the Streamlit package and Azure Computer Vision Services. Let's get started. I'll be using Visual Studio Code, but you can of course use the code editor of your choice. To manage the dependencies, I will use ppnv. You can just install ppnv by saying pip install ppnv. Of course, before you need to have a version of Python installed. I will be using 3.10, but you can select any Python 3 version that you want. So if you don't have ppnv, just say pip install ppnv. You can also use pip and venv to manage your virtual environments and dependencies. I will be just using ppnv. So first thing we need to say ppnv install Streamlit. So this is our main package that we will be using. It will take a few seconds to get installed, but we can already start writing our code. So first off, what we are going to do is we are going to create the basis of our application. So we are just going to say import Streamlit as st. And then we are going to create a title. So we are just going to say st.title. And the title of our application, so this is basically the header that will be displayed on our web page, will be, for example, computer vision with Streamlit. You can give it whatever title that you want. Then we are going to prepare the form that will allow us to upload the image. So let's say uploaded file. This is where we will keep the uploaded image for further processing, and we will just select say st file uploader, choose image just to give it a label, and then the image type should be a JPEG or a JPG. I'll now save it, and now let's see if this has worked. So what you have to say is ppnv shell in order to activate the virtual environment created with pipenv, and now what you can say is Streamlit run app.py. And now a browser should open, as it now did for me, and we should see our title that we have just created and our button that allows us to upload some files. Let's now display the image that we have uploaded. For this, we will need one more dependency. So I will just stop our application by pressing Ctrl+Z, and I will say ppnv install pillow. So now pillow is a package that will give us an image class. So I'll just say from pil. Once this is installed, this will be available to us. I'll just say from pil import image. And now below here, I will say if uploaded file. This just means that if a file has been uploaded, what we will do is we will create the image using the image class and then an open method, and we will open the uploaded file. What this will allow us to do is to use the streamlit.image method to display the image on the page. So I'll just say the image here, and then you can also give it a caption, for example, uploaded image. This will allow you to display the image on the page. As the last thing in Visual Studio Code for now, what we will do is I will just say if st.button, so to create a button, analyze image. This will be our analyze image button, and for now I will say pass here. This will just create the analyze image button on our web application. So now everything has been installed. Let's say Streamlit run app.py. Let's just check if it works. We have our application right here. I will select the same picture that I did in the intro, and we can see that it has properly displayed the picture here, and we have the Analyze Image button. However, for now, it doesn't really do anything once we press it. So this is what we will work on right now. In order for us to get access to the Computer Vision API from Azure, you need an Azure Cloud account. You can create one for free, and I will leave you a link to a video where I explain how to do it in the description. But once you have your account, you should have access to portal.azure.com, and here you just click on Create a Resource. In the search bar, just type Computer Vision and find this resource. Make sure it says Computer Vision and make sure it's an Azure service. Now click on Create Computer Vision. Select your subscription, select your resource group. If you do not have a resource group, you can just create a new here. I'll just select one that I created before. So I'm in Europe, so I will just select Europe. I will give it a name. So I'll say Tomek in Tech Computer Vision. Pricing tier, you select the free pricing tier, and now as you can see, this project in general will be for free when we use this Computer Vision API. Now let's agree to the terms of service, review and create. We need to change one more thing. Just ensure that in the network you have that all networks can access this resource. We can go back to review and create and just hit create. And I will see you once this deployment is finalized. Once your deployment is finalized, you should see a page like this. Now click on Go to Resource. And in this resource, what we are interested in is in resource management and in keys and endpoints. Here you will see your API endpoint and your API keys. I can even show you now the keys. I will remove the resource before uploading this video, but this is what we will need for our application. Back in Visual Studio Code, what we need to do is we need to manage these API keys and endpoints as our environment variables. For this, I like to use a separate package. So theoretically, you could handle this with ppnv, as if we just create a .env file and the ppnv shell is activated, it will automatically read the environment variables. However, for the purpose of future deployments, so in the next part of the video, I will show you how to deploy this using Docker to Azure. An additional package will come in handy for us. So for now, what I will do is I will say ppnv install, and I will install python-env. This python.env package will allow us to manage our .env variables. So here I will say from .env, I will import load.env function. I will immediately call this load.env function. It will just read the variables that we will have in our .env file that we'll create in a second. So before we create the variables, let's create here a piece of code that will read them. So we will need two variables. We will need a vision key, which we will get using the OS package, which means we need to also import OS here. And then OS, from the OS package, we'll use environ function, and we will just get a macro variable that we will call vision key. Below that, we will also create one for the vision endpoint. As always, in a try and catch block, here, if something goes wrong, we'll just say missing required and variables, and we will exit to stop executing any further code. Okay, now we need to create the file. So let's hit new file, let's call it .env. And here you need to paste the vision API and vision key and vision endpoint that we have just seen in Azure. So I will just copy this, remove the spaces, and copy the values from the Azure portal. Just as a reminder now, you should copy one of these two keys and this endpoint that you see here. I have now done it, and these variables are the so-called secrets. So these you should not show to anyone else. I'm currently showing it to you, but I will remove the resources immediately after recording this video, so before this is uploaded to YouTube. Okay, so now we have the environment variables that will allow us to connect to the Azure Computer Vision API. Now we need to install Azure AI Vision SDK. In order to do that, we say ppnv install Azure AI Vision -image analysis. And this should install the Azure SDK for image analysis. So now let's say from azure.ai.vision.image analysis, we will import the image analysis client. What you can see here is that my interpreter doesn't recognize that I have this installed, this package installed. What you need to do to change your interpreter, just click here, look for the interpreter that you are currently want to be using. Now it has recognized it. We can use this image analysis client. So what I will say here, right after we have read in the environment variables, I will just say client equals image analysis client. Will create an instance of this class where the endpoint that we will be using is our vision endpoint, and the credential will be provided by the Azure key credential class. Import from azure.core.credentials. So this we have also installed with the Azure SDK. We want to import Azure key credential class. And we need to use this Azure key credential right here. And as an argument here, you pass in the vision key. This will allow Azure SDK to generate the credentials we need to access our image analysis client. Next step is we need to pre-process the image. This means we need to pre-process it so that we do not need to upload it and pass in a URL to this image, but we will just be using a byte representation of the image. So we can do it right here immediately after it's uploaded to limit the time between the Analyze Image button is pressed and the results are displayed. So we will do it immediately here. So we'll just say images or image bytes. We will use IO package that we need to import. So we'll just import IO. With this IO here, we'll just say bytes IO. Bytes IO. And we will use this bytes IO right after we save our image. So we'll use this image bytes instance to save our image, and then in the format that we have on our uploaded image. And the image bytes, we will just get the values, get value from above. This image bytes will be a byte representation of our image that we will send to the API. Now let's come down here. What we need here is a try and except block. For now, I'll pass the exceptions. We will see what we will do later. But in the try part of it, we will define visual features. Visual features is an API or computer vision feature from Azure that will allow us to tell the API what we want to get as a result. Because you can get many things where the tags and the captions that we will get are the most basic ones. There are also other accessible in the documentation. You can look them up. So what we need for it is we need the visual features class. So here, let's just say from Azure AI Vision Image Analysis.models, we'll be importing visual features. So we need this visual features class. Now we'll be using this visual features class right here. So we'll create a list where I will say what features we want to get. And what we want to get is tags. By the way, here you can directly see what is also available to you. We'll take tags, we'll take caption, and we will take dense captions. So just an alternative description. These are our visual features, and now we are ready to make the API call. So we will store the result in a variable, and we will set a client. So this is an instance of the image analysis client class from above. We will just say client.analyze. And here we'll pass image data. So this is our bytes representation of the image. And we will pass our visual features. This is what we want to get from the API. Now, next step is we need to display the results of the analysis. So below here, we will just say if result.caption. So basically, if the result contains a caption, what we will do is we will just write in our web app caption. And below that, we will write st right with an f string what the actual caption is. So we'll just say result.caption.text. And then we will also print the confidence of the caption. So basically the confidence is saying how confident the model is that the caption is accurate. Of course, the higher, the better. Let's also make it an f string. And we'll just say result.caption.confidence. And we'll format it nicely. And this should display our caption. Now, next thing we want to display is we want to display our descriptions, so our dense captions and our tags. For this, we will just say if the length of result.dense_captions.list is higher than 0, because if it's not higher than 0, it means it's empty. We don't want to display it. And for this, we will just say st.write dense captions and then st.dataframe result.dense captions.list. So this will just create a nicely formatted data frame for us. Okay, we have done quite a lot. We still have some parts to add, but for now, let's see if our application is right now working. Let's clear the terminal. Let's say Streamlit run app.py. Oops. App.py. And to fix the error that we have just seen, I just had to close and open Visual Studio Code once again. So now I just set Streamlit run app.py once again, and what we can see here is that here we have our application. So what I will do right now is press Browse Files, load our Eiffel Tower picture once again, and press Analyze Image. And this time I'll be expecting some results. So first off, what we have is a caption with a confidence. So the caption says a large metal tower with a body of water and a road with trees and a sunset with Eiffel Tower in the background. So maybe a little bit weird with confidence 60%. However, we can see that it's a pretty accurate representation of the image. So it has recognized the Eiffel Tower. It has recognized also the body of water here and some trees. We also can see some dense captions, so basically some alternative descriptions of objects or parts of the image that are in the picture and where they are located in the picture. Okay, this works well, but that's not everything we wanted to do, because we still have some tags available to us. If you remember here, in the visual features, we also defined tags. So now let's go down here and let's do the same thing we have done above. So let's say if the length of the result tags list is bigger than 0, so if we have any, we will say, we'll just write tags, and we will also utilize the data frame to display a nice interactive table, and we will say result.tags.list here. So this will generate us a similar table as with the dense captions. And now here, instead of pass, let's just say st.error. And we can see here exception as E, that we are able to use this, or exception as E. st.error, and here as an f string, let's do, that should be here, say there was an error when analyzing the image. And we can put the error here. So now we have all the necessary parts. We have our environment variables, our image analysis client. In fact, we can put this inside of a try and accept. Well, we will just display an error that we cannot connect to Azure Computer Vision and stop executing. We have our connection to the Azure Computer Vision API. Then we have our part that preprocesses our image. We have all of the visual features that we want to get, and we are displaying the information. So now I'll save this and let's go to the website once again. So we are here. Let's click on Browse Files, that we can select something different right here. Let's click Open. Now we have this nice kitchen picture. Let's see what happens if we analyze this. And we get a description, a kitchen with table and chairs, which is accurate. We have some alternative captions. A kitchen with table and chairs, this we have seen. A chair with seat cushion and close-up of glass jar. A light fixture from a ceiling, bowl of fruit. That we don't really see here, but a light fixture we do indeed see. Let's see the tags. It's indoor, that's correct. We have a countertop, we have some home appliances, furniture, kitchen appliances, wall, cabinetry, chair, sink, kitchen and dining room. This is all accurate. And of course, you can kind of try to improve these models. You can play around with the parameters in the Azure OpenAI, or in the Azure Computer Vision, sorry. But this is where we will end today's video. So for now, we have an application that works locally. In the second part of this video, I will show you how we can make small changes to the application, create a Docker file, and deploy this application to run in the Azure cloud very, very simply. For now, thank you all for watching, and I will see you in the next video.